So hi children, in that synopsis, before that worksheet, in that synopsis of rectangle and rhombus, I asked you one question, no? Did you remember that? Okay, once again I will ask you that. So what is that question is, if in a quadrilateral, adjacent, at least one pair of adjacent sides are equal and it is having at least one angle is equals to 90 degrees. Okay, then what we will call that figure? What we will call that? Yes, that is nothing but a square. What is that? Square. A, B, C, D, one of the quadrilateral they given. Here how we can say that this quadrilateral is a square? How we can say that? Yes, in a parallelogram, if that adjacent sides, at least one pair of adjacent sides are equal and at least one of the angle is equals to 90 degrees. So once again I am saying that in a rectangle related to that parallelogram we discussed about that only angles, and come to that rhombus related to that parallelogram we discussed about that sides. Now we are going to discuss about that sides of a parallelogram and angles of a parallelogram. So what is that? In a parallelogram, if at least one pair of adjacent sides are equal and at least one interior, each interior angle is equals to 90 degrees, then it is called a square. Then it is called a square. So if you take that rectangle, so from that rectangle, is it possible to write that definition of a square? Yes. How it will be? Yes, say that in a rectangle, each interior angle is equals to 90 degrees. So if at least one pair of adjacent sides are equal in a rectangle, then it is called a square. Okay. And from that rhombus also we can say that in a rhombus, at least each interior is equals to 90 degrees. In a rhombus, each interior angle is 90 degrees. Why? Because in a rhombus means all sides are of equal length. We know that in a square also all sides are of equal length. So in a rhombus, here in a rhombus not all sides are of, all angles are of equal. Okay, all angles are not equals to 90 degrees also. So that's why if in a rhombus each angle is equals to 90 degrees, then it is called a square. Okay, and in the same way in a rectangle also all angles are 90 degrees. Each angle is equals to 90 degrees. Okay, and in a square also each angle is equals to 90 degrees. So that's why in a rectangle at least one pair of adjacent sides, are equal, then automatically another pair also, here we can say that another pair of opposite adjacent sides are equal. Okay, now that rectangle become as a square. Now here rectangle become a square means when it is possible, if it's at least one pair of adjacent sides are of equal, then only we can say that that is called a square. Okay, so that is the definition of that square from that rectangle. And related to that angles, we said the definition depends on that rhombus we said. Okay, from that parallelogram, in a parallelogram we have to see that sides as well as angles also. Okay, so once again I am saying the definition of a square related to that parallelogram. So in a parallelogram, at least one pair of adjacent sides are equal and at least each interior angle is 90 degrees, then we can say that one as a square. Okay children, is it clear to you? So what are the properties of a square? So here from that parallelogram we can derive that square. From that rectangle we derive that square. As well as from that rhombus also we can derive that square. So here why can't we say that all the properties are related to parallelogram, rhombus and rectangle? Those all properties are related to square are not here. Yes or no? In that parallelogram we derived, from that parallelogram we derived that square. So here we can say that all the properties of parallelogram related to square also, no? And in the same way from that rectangle also we derived that square here. So what properties related to rectangle? In a rectangle parallelogram properties there. Along with that parallelogram properties we have that two other properties there. What are those? Each interior angle is equals to 90 degrees and diagonals are equal. So here we can use that. Okay, and in the same way related to that rhombus. Rhombus properties also related to parallelogram. Along with that we have two properties. Okay, those Three properties, those three properties also belongs to square. Okay, so that's why before going to read about that square, you have to learn the properties of a parallelogram and properties of a rectangle, properties of a rhombus. Then only you can simplify the problems related to square. Is it clear, children? So here this is about that square. Okay, so after that square we have that special kind of quadrilateral. What is that? At that starting I told you that what is the special kind of quadrilateral? That is nothing but a kite. What is that? Kite. So this is that special kind of a quadrilateral, no? So what is the definition of that? It means here in a quadrilateral, at least here two pairs of, okay, one pair of adjacent sides are equal, means here we can't say that AB and BC. Those two also adjacent sides only. But here AB not equals to BC. So that's why here at least one pair of adjacent sides are equal. As well as two pairs of adjacent sides are equal. Two pairs means here we have to conclude that here AB is equals to AD. AB is equals to AD. And we can say that BD is equals to, BC is equals to CD. BC is equals to CD. Is it clear, children? In a quadrilateral, if that at least one pair means this is one of the pair and this is another pair. Okay. So here we can say that two pairs also, but here AB and BC also adjacent only. But here these two sides are not equal. Okay, so here in a quadrilateral, if AB is equals to AD, in a quadrilateral ABCD, if AB is equals to AD and BC is equals to DC or CD, then it is called a kite ABCD. That is called a kite ABCD. Here ABCD is a kite. Therefore, ABCD is a kite. Okay, children. So, this is the definition of a kite. Now, here what are the properties of a kite? Okay. So, here the first property is a kite has here two diagonals. No. So, those two diagonals bisect. I mean, one of that diagonal bisects that other diagonal. Bisects that other diagonal means here we can observe that two diagonals, the longest diagonal and the shorter diagonal. Okay, shortest length of diagonal and here longest length of the diagonal. So when you observe these two diagonals, here the longer one divides that shorter diagonal into two equal parts. Shorter diagonal into two equal parts. And in the same way, these two diagonals also perpendicular bisectors. Perpendicularly bisectors means not here another one. Shorter diagonal not divides that bigger diagonal into two equal parts. Okay, one of that diagonal, at least one of the diagonal divides that another diagonal into two equal parts, which means bisects that other diagonal. Is it clear? And in the same way, at least one diagonal bisects its vertex angle. So here we can say that bisects at vertex angle means vertex angles divides into two equal angles. Okay, which means here x and here also we can say x. Here it is y, then here also we can say that is y. At least one of the diagonal bisects its vertex angle. Is it clear? And the last property is the two diagonals at least here divides it into any one of the diagonal of a kite divides it into two congruent triangles. Okay, what is that? At least one of the diagonal divides that kite into two congruent triangles. Is it clear, children? So this is that special kind of quadrilateral. So up to here classification of quadrilaterals completed. So after this video we will discuss about that worksheet. So after completion of that worksheet, again in that synopsis we have that midpoint theorem. So in that synopsis video we will discuss about that midpoint theorem. Okay children, thank you.